So this is section 3.1.3.2. These are the notes for 3.1 and 3.2. Probably have to make two different videos for them. So a matrix is a rectangular array of elements, usually values, variables, or expressions. The size or the order of a matrix is given by this symbol right here. M standing for matrix and then A by B. Not times B, but kind of like if you were referencing the board 2x4. So it's a 2x4. A matrix of a 2x4 would have 2 rows and 4 columns. So where A is the number of rows and B is the number of columns. Every element in the matrix has a position based on its row and column. So A, 1, 2 is in the first row, second column of matrix A. So first row, second column, A12 would be 3. So these are examples of matrices. They're all different sizes. So it says state the size of each matrix. This matrix, A, would be a 2 by 2 because it's got 2 rows, 2 columns. This matrix B would be a 3 by 1 because it has 3 rows, 1 column. C, 2 rows, 3 columns. D, again, 2 rows, 2 columns. E is 3 by 3 with 3 rows and 3 columns. What is C21? So C, second row, first column, would be 3/4. C, first row, second column, would be 9. C, third row, second column, does not exist. And D, third row, second column, again, does not exist. An equality means that two same size matrices are equal only if each corresponding element is equal. So, for example, we can see that this is 3, this is -1. They're both a 2 by 2. If this were equal to 2 and this were equal to 5, then the two matrices would be equal. When you transpose, you switch rows and columns in a matrix, and this will make more sense when we do them. Adding and subtracting can be done by same positions only. So, for example, these two could be added, these two could be added, these two could be added, and these two could be added. There are two types of multiplication, and the first one is done in 3.1 and the second one is 3.2. But scalar multiplication is kind of like distributive, where you multiply everything inside the matrix by the same value. And matrix multiplication is when you multiply two matrices together. So, examples. Find the following using the matrices from above. I believe, okay, so A equals D. If A were to equal D, then we could say that W minus 1 equals 2. And then we would have to solve. And so W would be 3. Not the whole position, but just the W would equal 3. The whole position equals 2. This whole position equals 5. So we could say 2y minus 3 equals 5. Add 3. So 2y minus 3 right here is equal to the same position here. And so 2y minus 3 equals 5. We add 3, we get 2y equals 8. Divide by 2, we get y equals 4. So here in matrix D, we can find that w equals 3 and y equals 4. However, the entire element equals 2. This entire element equals 5. B says to -2 is a scalar multiplication of A. So that would look like this. Plus the transpose of B, which means we take the row and make the column. Sorry about that. But B transposed would be taking the row 2 and making it a column. So it would actually just look like this. 2, 0, -1. The row 2 became a column of 2. The row 0 became a column of 0. And the row -1 became a column -1. So this is all number 2. So here we can scalar by multiplying each element inside by the scalar multiplier of 2. But when we go to try and add the 2, we cannot because we do not have the same size. This is a 2 by 2. This is a 1 by 3. If they are not exactly the same size, they cannot be added or subtracted. So B, if we look at B plus C, B plus C. B is a 3 by 1, C is a 2 by 3. They are not the same size, so they cannot be added together. And then the last 3 we will get to in section 2, 3.2. So let's come up here and look at this next page. The size of a matrix is written in what order? Row by column. Write the size of each matrix of the following. So A would be a 2 by 3. 1, 2, 1, 2, 3. B would be a 1, 2, 3, 1, 2, 3. A 3 by 3. C, 1 row, 3 columns. D, 3 rows by 1 column. E would be a 3 by 3. And F, 2 by 3. In matrix A, what is the address of the element -6? So here's -6. That we would say A, row 2, column 3. In matrix A, what is the address of -1? So A, row 1, column 2. When you're writing the addresses or the location of each element, you do not put the by symbol, the X. Find B, 3, 2. So B, 1, 2, 3, column 2 would be 4. And F, row 2, column 1 would be 1. The negative of A, so we would go -4, -1, 5, 2, 3, -6. So what we're doing is we're just changing each element to its opposite. You don't have to have the positive there. A plus F. So A and F, they are the same size. So A is 4, -1, 5. 2, 3, negative 6. So you just add the addresses together, basically, each element together in the same location. So if I start with the 2 by 3, I'm going to end with the 2 by 3. So 4 plus 4 is 8. Negative 1 plus negative 3 is negative 4. 5 plus 0 is 5. 2 plus 1 is 2. 3 plus 9 is 12. And negative 6 plus negative 2 is negative 8. So that's adding the two of them. Subtracting, same way. You subtract same elements or same locations. So 4 minus 4 would be 0. Negative 1 minus negative 3 would be positive 2. 5 minus 0 is 5. 2 minus 1 is 1. 3 minus 9 is negative 6. And 6 minus negative 2. Oh, wait, is that a 6? Yes. Oh, that's a negative 6. My bad. Negative 6 minus negative 2 would be negative 4. In adding and subtracting, whatever you begin with is what you will end with. C and D. If we tried to add C plus D, C is a 1 by 3, and D is a 6 by 2, a 3 by 1. So you can't add because they aren't the same size. So we would say no solution, not the same size. Sorry. Scalar multiplication is where you multiply each element inside by the element outside. So that would be, this is F, 2 times 4 is negative 8, positive 6, 0, negative 2 times 1 is negative 2, negative 18, and positive 4. And then this one, 3a plus 2f. So that's saying 3 times matrix A plus 2 times matrix F, and then adding the two together. So I'm going to leave that for you to do, and you can check with me in class. Make sure you ask. And on this one, to add the matrices for January and February, this matrix would be 44, 36, 55, 48. This matrix would be 24, 32, 40, 46. And because they are the same size, we could add them together. 68, 68, 95, 94. So, and this is the end, and I will start a new video for 3-2.